you can see that the red car is going at a constant velocity. So it is going in that direction and the green car is coming in that direction, and they both start at the same time. So when they meet somewhere here, let's say, they both have traveled the same amount of time, because they meet at at the same instant, because when they meet, that means both have traveled the same amount of time. Now this one goes at a constant speed while this one goes at a constant acceleration. So if as it is going at a constant velocity, so we know the equation will be x is equal to vt, because it's constant, no acceleration. While for green car, the equation will be x. Instead of s, I'm writing x. That will be, let's say this is VR probably, because red car, and this will be V naught. Instead of U, I am using V naught G T plus half a t square. This is modified because it has an acceleration. For this one, this is the same equation for this one, for the green car, but acceleration was 0, so this term became 0. Now we will use this equation because we know the velocity, the constant velocity. Also we know at what distance they meet. That means at what distance from the red car they meet. That means we know how much the red car has traveled. So that will be, for the first case, that will be 244.8, and here velocity I will convert that into meter per second, so that will be 27 times 1000 meter, and then second will be 3600, 60 times 60, and that gives me 7.5. so times t is what we want to find. So the t you get is 5.98. This is the t that I got. So after that much time they met. That means the green car also has traveled this amount of time. So the equation we will get from for the green car will be x equals to v naught g t plus half a t square. Now we don't know v naught g, we don't know a either. Instead of v naught g, I will just write vg probably. That will make life easier. So vg, that means the initial velocity. Usually it was written as u in previously, but this is okay. So like that. And what we don't know is what is x. We actually know because the total separation between these two is 220. So 220 minus 44.8 will be the distance that the green car has traveled. So that will be v naught, and then t is here 5.98 times 5.98 plus half a 5.98 whole square. So this is not a decent values, all those things, they are very. So what I got there is 175.2 here. 175.2 is equal to v 5.98 vg, and this one squared, so that was 17.8 a. So this is one equation. Similarly, there is a case 2. That means when the car's velocity is different, we get, for case 2, let's say case 2, now x is equal to VRT again. Now we will get a different t because they meet 76.8 is that thing, and VR is now 54, so it's just twice. So that will be, we can see that it's twice because it was 27 earlier, so 15, but you can find that with 54 times 1000 divided by 3600 will give you 15. So 15 times t, so t now becomes 5.12 second. So it is bit less, it was 5.98 previously. So for green car now, the equation now becomes again x is equal to vgt, the same equation, plus half at square. Now x is now 220 minus 76.8, That's the distance that green car has traveled, because the red car has traveled this much, so the separation is 220. So the green car, when they meet, must have traveled 220 minus 75, 76.8. So that one, 5.12 times Vg plus half A, 5.12. The numbers are a bit nasty, but what I got now is, so that's 143.2 equals to 5.12 Vg plus 13.11 A. So that is equation 2. So this one was equation 1. I have written the conventional right hand side on the left hand side, but maybe I can rewrite this one. That will be, or maybe I will rewrite over there. So 5.98 Vg plus 17.8 is equal to 175.2. 17.8 A is equal to 175.2, I guess. And for this one, 5.12 Vg plus 13.11 A equals to 143.2. So these are the two equations. So now look at this equation. If we want to multiply this one with something to make one of the variable disappear, it will be a bit difficult to find. So that's why we should use the standard form always. So Vg will be, as from the determinant method, it will be 5.98, the coefficient of these two. Maybe I will use a different color, I don't know. So this one and the, sorry, that's a plus sign anyway, so that is the coefficient, and here we have the constants. So 5.98, 5.12, and here 17.8, 13.11. it will be same for both, and the numerator will be, since we are trying to find Vg, that will be 175.2 here and 143.2 here, and here we will have the same thing as the denominator, that will be 17.8 and 13.11. Now what will happen is, we need to multiply Vg, so that will be, if we do the multiplication, that is 5.98 into 13, 5.98 into 13.11 minus 5.12, sorry, 5.12 into 17.8, was it 17.8, and here we have 175.2 into 13.11 into 13.11 minus 143.2 into 17.8, 143.2 into 17.8. So once we do that, what I got is 19.7 something meter per second. So you will get this as negative, this as negative, both will be negative, so the negative will get cancelled, and this will be like that. But remember that the velocity of car A is in that direction, so the velocity of this car is in the other direction. So you have to write, since this is in the opposite direction, the velocity Vg will be minus 19.7 basically, and you can write that directly. Just you have to write here that since this is going in the other direction, the velocity will be negative. Similarly for acceleration, it will be the same thing, and the denominator will be the same basically. So this thing will be in the denominator, numerator will be a bit different. So a bit different means it will be, so 5.98, 5.98, 5.12, 17.8 and 13.11, and here we will have, since this is A, so that is like y in normal algebraic equation, so this will be the same, but this side will be 175.2 and 143.2, and once this is again can be solved by multiplying these two minus these two, so from these two to these two, and this will be the same as before. And what I got here is approximately 3.19 or 3.2, and again since the acceleration is also in the other direction, so that will be minus 3.19 because meter per second square, because the green car's velocity and acceleration is to the right, so the red cars was to the right, so the green cars will be to the, as it is to the left, it will be negative. So because this was positive, this will be negative. That's how it works. So yeah.